Welcome to our part 2 of our review video. In part 2, I'll be discussing about the metalization process. Metalization process is a device fabrication process where we stack or put our metals onto our finished device. And the metals we'll be putting on will be on the gates and the source drains and other planes if it's necessary for our fabricated device. So as we learned throughout the course, we need to have a low source drain resistance, or hence contact resistance, for our maximum efficiency on our finished device. So in metallization, there is a process called silicide, and the silicide is a compound that mixes between silicon and the metals. And the concept of silicide is that if we put our bare metals onto our bare silicon, that creates a Schottky junction, as you guys already knew that. So in the Schottky junction, because of the Fermi level pinning, the electrons have to jump through a large gap or a high wall. However, if we put a silicide on it, the work function between the silicon and the metal, the silicide will work as a stairway or just a stepping stone for easier electron jumping or access through the metals, hence a lower resistance. Not only we could achieve a lower resistance by changing the material properties on our materials, but also the materials on the metals where we use for metallization process, and that is called a damascene process. Damascene process, we use copper because copper has a low resistance, so we can achieve some profits there. However, there's some problem. Copper usually diffuses through the silicon if we use the bare copper. So we implant the damascene process, and we'll be looking like this. And the idea of the process is we use another layer of metals to coat the silicon. So the copper we pour in for our metallization doesn't diffuse into the wafers and create some problems. Well, that's about it. Thank you for listening, and thank you for watching.